Welcome to Algebra 1. The learning goal for this episode is to learn what a quadratic function is and how to graph quadratics in the form y equals ax squared plus c. First, some necessary vocabulary. A quadratic function is a nonlinear function that can be written in the standard form y equals ax squared plus bx plus c, where a is not equal to 0. Every quadratic function has a U-shaped graph, either a right side up U or an upside down U, called a parabola. In this video, we're going to focus only on quadratics where b equals 0, so they're in the form y equals ax squared plus c. The next video will deal with when b has a value other than 0. Y equals x squared is called the parent quadratic function. We're going to look at it first to get the general idea of how to graph quadratics, then move on to other quadratics. Here's a table of values for y equals x squared. I picked several values of x, including 0, positive values, and negative values, and then squared them to get y. When we graph those ordered pairs and connect them, we notice several things. First of all, the graph is not linear. It's curved in a shape called a parabola. This parabola is a right side up U shape, and its lowest point, called the vertex, is 0, 0. If it was a downward shaped U, then the vertex would be the highest point. Parabolas also have a line called the axis of symmetry. This line passes through the vertex and divides the parabola in half into two symmetric parts. For this parabola, the axis of symmetry is the vertical line x equals 0. Notice how any point on one side of the axis of symmetry, like the point 2, 4, has a symmetric point on the other side of the axis, negative 2, 4. This is always true about parabolas. They are always symmetric about their axis of symmetry. Let's look at some examples where the absolute value of a, the coefficient of x squared, is greater than 1. So for this first example, we'll look at y equals 2x squared. I start with a table of values where I pick 0 and a couple of points on either side of 0. When I plot those points, I get an upward facing parabola with a vertex of 0, 0. Notice again the symmetry. Now how I have a point on the right side, 1, 2, and a symmetric point on the left side, negative 1, 2. Then the same thing with 2, 8 and negative 2, 8. Now let's compare this graph with our parent function y equals x squared graphed in purple. Notice how y equals 2x squared is narrower than our parent function y equals x squared. Or you could say that y equals x squared is wider, however you'd like to look at it. Let's look at another example where the absolute value of a is greater than 1, but this time a will be a negative number. Again, I make my table of values. Remember order of operations here. You need to square x first, then multiply by negative 2. This time when I graph the points, it is a downward shaped parabola. My vertex, which is now my highest point, is still 0, 0. We still have an axis of symmetry on the line x equals 0. Any point on the right, like 1, negative 2, has a corresponding symmetric point on the left, negative 1, negative 2. Now let's compare it to the parent function y equals negative x squared in purple. Again, notice how y equals negative 2x squared is narrower than y equals negative x squared. This leads to the following generalization. When the absolute value of a is greater than 1, the graph will be narrower than our parent function y equals x squared. And when a itself is negative, the parabola will be an upside down U, or downward facing. So now let's examine what happens when the absolute value of a is less than 1. For this example, y equals 1/2 x squared. I make my table of values first. Now I graph it. Again, notice the symmetry. Now if I compare it to our parent function in purple, y equals x squared, you'll notice that this graph is wider than our parent function. So let's take a look at another example where the absolute value of a is less than 1, but this time a is negative. I make my table of values. Now when I graph it, notice that the parabola is downward facing. If I compare it to my parent function, I notice that it is also wider than the parent function. Which leads to our second generalization, that if the absolute value of a is less than 1, the graph is wider than our parent function. And it's still true that if a is negative, our parabola will face down. Now what happens when we add a constant to our graph, a value for c? In this case, y equals x squared plus 2. First, we make our table of values. Now we graph it. What do you notice? If we compare it to our parent function, the vertex is shifted up 2 units. All other points are also shifted up 2 units, but it has the same shape as the parent function. So now let's look at y equals x squared minus 2. We make our table of values, and now we graph it. What do you notice this time? Hopefully you notice that the vertex and all other points are shifted down 2 units, but the shape is the same as our parent function. So this gives us our third generalization, that when c is greater than 0, the graph is shifted up by c as compared to our parent function. And when c is less than 0, our graph is shifted down. Now let's put this all together in this example, y equals negative 2x squared plus 3. Look at the negative 2 and at the positive 3, and you should be able to predict what the graph is going to look like. Since a equals negative 2, we know it's going to be an upside down u that's narrower than our parent function. And since c equals 3, we know it should also be shifted up by 3 units. So here's our table of values, and here's our graph. Here's the parent function for comparison. Notice how our graph is shifted up 3 and also narrower. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is graph this quadratic equation. How do we do that? First, we should identify our values of a and c so that we can predict what our graph should look like. Now what? Now we should note the graph will go up, be narrower than our parent function, and be shifted down by 6. So what do we do next? We make our table of values. Now what? Now we graph the points, connect them in a U-shape, and make sure our graph matches our prediction. It does, so we're done. Let's try another one. What do we do first? We identify A and C. Now what? Now we predict that this will be downward facing, wide, and shifted up by 3. So what's our next step? We make our table of values. Now what? Now we graph it. Anything else? We should make sure our graph matches our prediction that it's downward facing, wider, and shifted up by 3. It does match, so we're good. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn what a quadratic function is and how to graph quadratics in the form y equals ax squared plus c. We did this by learning that a affects the width and the direction of the parabola, and c shifts it up and down vertically. If the absolute value of a is greater than 1, then the graph is narrower than our parent function y equals x squared. If the absolute value of a is less than 1, then the graph is wider. If a itself is positive, then the graph opens up. If a is negative, then the graph opens down. If c is positive, then the graph is shifted up. And if c is negative, then the graph is shifted down.